Yeah, I have a YouTube channel. It's all posted to YouTube. Yeah.
Are you giving out extra credit this year?
Oh, that's a good question. I plan to. Yes.
If I subscribe to your YouTube channel, can I get a drink?
No.
I'll subscribe to it.
So my YouTube channel is Miss G's Math Class. All last year I left it unlisted. So what that means is it's not available. So like if you were to search for my channel, you wouldn't find it. But I decided that this year I'd go ahead and make those videos public. And we'll see how many kids I maybe help this year. I think it'll be kind of funny.
Like Clan Academy.
Khan Academy.
It's okay.
Miss G's Khan Academy. All right, so before we get started, I just want to refresh your memory about a few more exponent properties. And those exponent properties are a little more obscure, a little less known. So first of all, what time is it? Stupid alarm. It's 1:38. It goes off twice a day. Every different hours and a half a day.
Fire drill?
Did you?
Running a fire drill?
No, not fire. It's a bomb.
I know.
It's that box next there. Yeah, you guys are going to do those. Yeah. All right. So sorry about that. So couple of lesser known exponent rules. If you have the same base, what are you allowed to do to the exponents? Add them, right? Okay. And what if you have a division problem?
Subtract.
Oh, but wait a minute. If I have a division problem like this, that the base stays the same, how do you subtract?
1 over X.
Okay, so I'm hearing answers, which you are correct. So, but how do you subtract?
The
You take
bigger
the
one is
denominator,
the dominant one.
the power of the denominator and subtract it by the numerator.
So,
Or no.
okay. So the technical rule is the base stays the same, and you do top minus bottom, 3 minus 4, and that's how it's defined, top minus bottom. And you'll notice when you get this answer, it's x to what power? Negative 1. What does a negative exponent do? Oh, it flips it under. Yeah, so it flips it underneath. So this is 1 over x to the happy first power now. I think about negative exponents as happy or sad. That's my highly mathematical thinking, okay? He's negative. He's unhappy. He doesn't like where this is. And so because he's got a negative exponent, he wants to be sent to the denominator, where he will now turn to a lovely positive 1. Positive, happy, right? So the reverse is also true. If you have like 3 over x to the negative 1, what can you do with that negative exponent?
Make him happy.
Make him happy and put him up top. That's right. What about this? What does the 3 do? It just stays. Why does it stay? It's happy. What's its exponent? 1. A nice little positive 1. So he doesn't want to move, but this guy does. And so 3 is going to stay, and x is going to turn up to the numerator now. If you want to put the 1 in the denominator, go for it. It's great. It's a good reminder. So the rule actually is when you use this rule, it is defined as using it and being in the numerator, top minus bottom, and then you would move. Now, what I love is that all of you were like, it's 1 over x. Fabulous. I'm glad you can recognize that there's a whole lot of x's here. There's more on the bottom. They would cancel out. I love that you can just see that you have a bunch of x's that would cancel out. You got an extra on the bottom. Okay? I want you to be able to do that, but you need to know all the rules. What is 249 to the 0 power?
1.
1. What is xy to the 0 power?
1.
No. Ah, I fooled you. What is it? It's x. Why is it x? Because the 0 affects only the y. Very good. So that is x times 1 or just x. Remember, any number to a power 0 is equal to 1. Almost, because what's 0 to the negative 1 power? Undefined. Very interesting. Very good. So 0 to the negative 1, again, you can think the same rule applies. He is unhappy where he is, so we move him to the denominator where now, yay, I'm a happy 0. But we say, can we divide by 0? No, it's undefined. And my favorite saying is when the 0 is under, it's undefined. When the 0 is under, it's undefined. And by under, I mean under the bar. All right? When the 0 is under, it's undefined. It's my favorite saying. And in this class, it's my job to make sure you learn that. Okay? Absolutely essential. When we have something that's undefined, I want you to think about it as slope. Okay? If something is undefined, like if it were a line, what would it look like? It's a vertical line. Okay, so whenever we run across something that's undefined, graphically we create this vertical line called an asymptote. A vertical undefined line that creates interesting anomalies in our graphs. Okay, and so pay attention to those. Very good, folks. Here we go. On notes, example 1, evaluate each expression is how I grade your notes. So please, please, please write down example 1 and the directions. Example 1, evaluate each expression. And I'm always going to encourage you, hopefully this is review. This whole semester should be review. All right? All we're doing is Algebra 2, and half of you came from college algebra. And so everything that I'm showing you should be old school. You should know this already, okay? This entire semester. If you can work ahead, please do, all right? Use your brain. Go faster than me. I'm only going to go as fast as the slowest kid in the class. That's what I try to do, right? It's usually not. It's a long day. It has more to do with the long day. I love you, honey. Okay. So, yeah. Right. But you are always the one that's like, wait. Can you go back? Yeah, wait. Okay. So, yeah. It's really because she likes to use the colors. She's really detailed. It's great, but she does like sleep with class too. So I'll try to. All right. There are all sorts of different ways that you can solve these problems. So I'm going to show you 1 or 2 maybe ways that you can do it. But know that this is not the only way. If you did it differently, fine. You probably did it just right. Okay. So there's a couple ways we could do this. 3 over 3 to the negative 4. What do you guys want to do? Make 3 to the negative 4 power happy. Okay, so a lot of people said that, move it to the top. So he's unhappy here, so he wants to go to the top. That's definitely a way you could do that. And so that would be 3 to the first power times 3 to the happy 4th power. And now they have the same base, and so what can we do? 3 to the 5th power. You can leave it like that. Or if you have a calculator, and it doesn't matter which type of calculator you have, you could evaluate it. Remember, my tests are multiple choice. And so if you don't see the answer listed, like if I had A, B, C, D there, and you didn't see 3 to the 5th, it's probably because I evaluated it. So 3 caret 5, that's how you get the power there. 3 to the 5th is 243, and it works the same on the Casio. 3 caret 5, that's that little caret symbol. That's a power up, a level up there. 3 caret 5, 243. It's always nice when your calculators agree. Is there another way to do this question? You can subtract the exponents, absolutely. So the other way to do this is we have 3 to the first over 3 to the negative 4. And I can use the subtraction of exponents. They have the same base, So we keep the base the same. And how do we subtract?
1 minus
1 minus a negative 4. And 1 minus a negative 4 is 5. So that also gets you the equivalent answer. Okay? All right. Letter B, 3 to the negative 1 plus 2 to the negative 2. What do you want to do? Make them fractions, make them happy. Okay. Yeah, we can absolutely do that. All right. So my first question to you is, can we use that property where they have, so we can add the exponents? Is that allowed? No. Why not? It's not, okay, it's not multiplication, and why else? It's not the same base. Very good. Okay. So big plus sign here is going to cause a big hiccup. So we're going to go ahead and morph these into their happy fractions. So 1 over 3 plus 1 over 2 squared, which is 1/4. Very good. And then we're going to do what? Common denominators. So we need to multiply the first fraction by 4 and the second fraction by 3 on top and bottom. And that's going to give me 4 plus 3 over a common denominator of 12, which is 7/12. Okay, and of course, when I'm teaching, I will always show you every single step. Okay, I feel that is my duty. I hope you copy down every single step because your notes are for reference. Okay, but if you don't need me to do that, then you can copy down what you need me to do. Now, I certainly want to see more than just the problem and answer. Okay, there should at least be a step in between. Okay, but if you can add 1/3 and 1/4 in your head, great. That's fine. Hello. Okay. Are these my calculators?
Oh, we're all getting calculators?
Oh my goodness. So last year.
What a waste of money.
So last year, my former students will remember I was trying to create a program where we can have loaner calculators, and so I asked all of my students to donate to my Donors Choose. Do you remember that? I created a Donors Choose. Well, at the end of the year last year, to get calculators so that we could have new calculators down in the finance office and it could be checked out like a textbook, right? Kind of nice. Well, my Donors Choose actually got funded, which is exciting. So I got 15 new calculators because that's all I could buy. But what's interesting, the really interesting part of how it got funded, it was only about half funded from myself and my family and some students. Okay, the rest of it got funded by what's that Korean pop group?
BTS?
Yes. 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 So what is the group that follows them? That they're like they have like a special name. I don't. We have, so yeah, the Thunderbolts Army. Yeah. So what's it called? Army. Yeah. So at any rate, I get all these messages that like so and so funded you. You know, #Army. You know, and I was like, what is this? What is this? So I had to like go on this like YouTube search and try to find out what this was from, and so they had posted, you know, this Donors Choose, and they highlighted some things, and it was basically some radio station out on the East Coast, and they got wind that there were some great projects out there that needed funding, and then all these people just donated from across the United States. I don't even know. From this army of fans who like this Korean pop group, and I mean, it was such a crazy thing. So I was incredibly, just wow that people would just donate. I mean, there were some people that I had no idea. I don't know who these people are. he donated hundreds of dollars to me. And I know, I was like, oh my gosh, that's amazing. So anyway, we are 15 calculators, more flesh here at Zorro. So let's give them a hand. And how about that? I think I probably will, but so because we will have to send them a thank you package, and I'll have to check, but yeah, it's kind of funny. Anyway, so here we go. Example 2, simplify and rewrite each expression with positive exponents. The positive exponents part, simplify with positive exponents. Watch, those are the real important parts of the directions. You're welcome to abbreviate the directions so I can get the key parts in there. We want positive exponents in our final answer. Whatever that happens to be, we would make sure we have only positive exponents left over. All right, so we have a to the negative 3 over b to the negative 1, quantity b over a cubed. What do you want to do? The negatives, you want to, what, swap a those? Yeah, okay. So this a to the negative 3 is unhappy, so he wants to move down, and the b to the negative 1 is unhappy, and so they want to move up. So, okay, so that's going to be b to the happy 1 over a to the happy 3, okay? In between here, what operation do we have between these? Yeah, sets there. Yeah, good. And then what happens here with this b over a quantity cubed? The exponent gets distributed. Yeah, multiply. So it gets shared. This is b to the first over a to the first. So this is a power to a power situation. And power raised to a power, you get to multiply those exponents. And so we're going to multiply, or some of you like to use distribute that power to each thing. And, you know, I always like to encourage you, we use these rules. It is b over a times b over a times b over a, if you were to write it out. Or b cubed over a cubed. So it's really, I always like to go back to just remind you what that meaning is. Repeat it 3 times. And then what can we do? Add the exponents. So they have the same base. We're going to multiply straight across there. And so we're going to keep the base the same. It's going to be b to the 4th over a to the 6th. Good, good, good. As long as a is not equal to 0. What happens if a is equal to 0? It's undefined. Yeah, very good. Okay. All right, letter B is really interesting. What do you want to do with letter B? Distribute your exponents? Okay, sure. So same idea here. That's a 5 to the first power. So again, we have that power to a power situation, and you can share that there. So that's going to be 5 cubed times x to what power? X to the 6 times z to the 18. I'm hearing mumblings. I think I know what you're talking about. So again, we have 5 to the first, so I will discuss that in just a second. We're going to share that power over here as well. So that's going to be 5 to the negative 3 times x to the negative 6 times z to the negative 18. And then when I want to go and think about those same bases, I've got 5 cubed times 5 to the negative 3, which would give me what? 5 to the 0 or 1. And what happens with x to the 6th and x to the negative 6? X to the 0 and z to the 0 as well, right? So we just ended up getting 1. Crazy. Could we have done that faster?
Yeah.
Oh, yeah. In this class, you know, I think it's a big learning objective for this level of math. We get wrapped up in the minutia of mathematics, following rules sort of blindly with blinders on, okay? So most of us go right in, all right, I'm going to share all those powers. Well, really, if you would step back and notice that, hey, this is my base. 5x squared z to the 6th times another base. to a power of 3. So whatever that is to the third power times whatever that same base is to the negative 3 power is going to give you same base, add your exponents. It doesn't matter what that base is. It's going to be 1, okay? In this class, it's really important to take a step back and really look for patterns. See if you notice things that match, all right? And so we're going to pay attention to that in this class, looking for patterns to make your life a lot easier. Now, the nice thing is no matter how you do this, you get the same result, all right? One's just the faster way to get there, okay? Do you have any questions for me? I was recording. And look at that, exactly 20 minutes. And I had like a 5-minute story in the middle, so pretty good.
Yes.